Hello everyone. From today onwards, I want to start the concept of oscillators. First, we'll see what is oscillator. Oscillator is an electronic circuit which will generate a waveform. Okay, so that is the definition of oscillator. In the previous videos, I explained different types of amplifiers. Feedback amplifiers and multi-stage amplifiers. In all those amplifiers, what we are doing is, we are giving an AC signal and those amplifiers will amplify that AC signal. Okay, and the output, we are getting an AC signal which is having higher amplitude. Okay, transistor will take the VCC and it will set its biasing, and means the transistor will enter into the active region. Then it will take the AC signal and it will amplify. That is the concept of amplification. But in the case of oscillator, yes, it produces a waveform. It won't require any AC input signal. Okay, so the other point is, this is the definition. The next point is, it won't require external AC signal. Okay, means without taking AC signal, it will generate a waveform. How it generates? That oscillator circuit will generate the waveform by taking the DC supply. Another important point. The point is, oscillator uses positive feedback. Okay. Yes, and the feedback amplifiers explain you the difference between positive feedback and negative feedback. Here also I will explain this positive feedback. Okay, the negative feedback is used in amplifiers and the positive feedback is used in oscillators. The applications of these oscillators. Oscillators are used in communication systems and in digital devices. I can say these two are the main applications. Along with these two, yes, the oscillators are used in our watches, clocks. See, what is this communication system application? In the communication system, we have a transmitter and a receiver. In the transmitter block, we have the concept of modulation. For the modulation, we need a carrier. Carrier is the main thing in any communication system because it is carrying the information. To generate the carrier, oscillator is used. Okay, yes, I think you heard about local oscillator. Local oscillator is used to generate the carrier waveform. Okay, and in digital devices, okay, this is carrier generation. And here, in the digital devices, you know about the clock. How is the clock? Clock is like this. Okay. Digital devices won't work properly without clock. In the digital electronics concept, you heard about various flip-flops, registers, counters. All those depends on the clock for the perfect operation. See, even in your watches, in the refrigerator, and for air cooler time setting, and for washing machine, the time setting concept is by the clock signal only. That clock is generated by the oscillator. Okay. Another important point is, we have mainly two types of oscillators. It means that classification is by the shape of or the type of waveform. Sinusoidal oscillators and non-sinusoidal oscillators. Okay. What's the meaning of sinusoidal oscillator? If the output is like this, like a sinusoidal, like this is sinusoidal oscillator. Non-sinusoidal, it may be like this square wave or triangular wave like this or sawtooth wave like this. Okay, oscillator which will generate these type of waveforms is called non-sinusoidal oscillator. Okay, and this comes under sinusoidal oscillator. Is based on the elements used. Oscillators are RC oscillators, LC oscillators and crystal oscillator. In our oscillators concept, Okay, I'm going to explain these three types of oscillators. Okay, so under RC oscillators, we're going to see about two types: RC phase shift oscillator and Wien-Bridge oscillator. And under LC oscillators, Hartley oscillator and Colpitt's oscillator. Totally, I am going to explain 5 types of oscillators. Now we'll see the oscillator principle or the concept of oscillator. To explain it, we need a block diagram, amplifier A, and the feedback network, which is having the factor beta, and this is X0. Take it in a general way, and this is given to the feedback network, and at the input side you have a summer or mixer. From this, the input is X, and from the feedback network to this mixer, another input will go, that is XF, and the mixer will give a signal called XI. So thus we know and the concept of feedback amplifiers. At this concept only I explained the difference between positive feedback and negative feedback. Now here I will explain about the positive feedback. So this, the amplifier output is given to the feedback network, and the feedback network output is XF, where XF is beta X0. Okay. Input signal for the mixer, the external source signal is XS, and these two will mix in the mixer. This is mixer. Okay, the resultant is XI. Okay, so what is positive feedback here? XS and XF. Yes, XS and XF must be in phase. Means the two must have same phase. Okay, then what will happen? Yes, if the two are same phase, Xi becomes XS plus XF. Same phase means, say this it is plus XS and this will be plus XF. So what the mixer will do? Mixer will add these two. So we will get Xi is equal to XS plus XF. What is happening in the negative feedback? XF is out of phase with XS. Means that XS is positive, XF is negative. Therefore, Xi becomes XS minus XF. That is negative feedback. Okay. But here, as the two are in phase, Xi becomes XS plus XF. So what will happen? Actually, we are giving external source signal as XS. But because of this feedback signal XF, totally Xi is more than XS. Okay. Means with the positive feedback, the original input signal for the amplifier increases. Okay. Yes, another point here is, by the positive feedback, input signal increases. Means Xi increases. If Xi increases, obviously X0 increases. If X0 and Xi both increases, then automatically gain will increase. Okay. So gain will increase with the positive feedback. These are all about the positive feedback. Now we'll see about this block diagram. In the first cycle, what is Xi? Xi becomes XS plus XF. We are getting one X0. And in the next cycle, what will happen? A fraction of X0 is again connected as XF. Okay. And initially, in the first cycle, it is Xi, that is XS plus XF. Now in the second cycle, another extra amount is adding to this Xi. So what will happen? Xi again increases, then X0 again more increases. Okay. Then gain again increases more. Then in the third cycle, again Xi increases because of this factor, and then X0 increases. So this goes on. So what will happen? Yes, gain is continuously increasing. That is about positive feedback. Yes, now we will derive gain with the feedback. What does it say? Gain without feedback. Now the gain with feedback is AF is equal to X naught by XS. So now you can write AF as X naught by, what is XS from this? XI minus XF. Okay. So divide the numerator and denominator with XI. So this is X naught by XI divided by XI becomes 1. Then XF by XI. Okay. So what is X naught by XI? See here, this is XI and this is X naught. So what is A? X naught by XI. So now you can write AF as X naught by XI is A by 1 minus, you will write it as XF by X naught into X naught by XI. So what is XF by X naught? See this beta? The beta network. What is the input? X naught. What is the output? XF. So what is XF? XF is equal to beta into X naught, implies beta is equal to XF by X naught. Okay. So now, so what you can write? You can write it as A by 1 minus XF by X naught is beta. X naught by XI is A. So totally your AF is A by 1 minus A beta. We know the same expression for negative feedback, it is A by 1 plus A beta. Okay. So now let's see about this A beta term. What is A beta? A beta is called loop gain. Now suppose if loop gain A beta is 1. So then what about AF? AF becomes infinite. A beta 1 minus 1 0. So AF becomes infinite. What is AF? X naught by XS. See, X may be voltage or current. Okay, we generally go with V naught by Vs. Okay. What is the meaning of infinite AF? Means infinite. When we'll get infinite? When the denominator is 0. What is the denominator here? Vs. Means even with the Vs is equal to 0, we are getting output. And in the starting concept, I mentioned one point. That point is an electronic circuit which will generate a waveform without taking any external AC signal. So here also what is happening? Even when Vs is equal to 0, we are getting V naught. So that is the case of oscillations. Okay, now means you can remove this excess. Okay, at that time, what is happening to Xi? Xi becomes your XF. Is it practically possible? Yes, it is practically possible. I'll explain that concept of generating the initial oscillations, oscillator by oscillator. But for the theoretical purpose, the concept is the first cycle, you have to apply excess. Whenever you get the output, you remove it. Then what will happen? X naught will be given to the feedback network and feedback network will generate XF and Xi becomes XF now. Okay, then no need of excess. But initially you must give excess, theoretically. But practically there is no need of giving excess. I think you did the experiments related to the oscillator, RC phase shift oscillator, Colpitt's oscillator, Hartley oscillator. For all those oscillators, yes, you are not connecting any AC input signal. Okay. So this is the concept of oscillations. Yes, now in the same concept, I will explain another important criteria. That criteria is Barkhausen criteria. What is this Barkhausen criteria? It is nothing but, or it gives the conditions to get oscillations. Barkhausen criteria is nothing but conditions to get oscillations. Okay, let us say the first condition. Yes, what is the first condition? See here. Even with the Vs is equal to 0, we are getting output. That is the concept of oscillations. Yes, when we got this Vs is equal to 0, when A beta is 1. So that is the first condition. The loop gain A beta must be 1. Or I can say the magnitude. That be magnitude. Magnitude of the loop gain must be 1. And the second point. Yes. See here. Here the output will increase continuously, because remember carefully, actually the oscillations are like this. Okay, the oscillations will start with a small amplitude and then the amplitude is increasing. At one particular point, amplitude becomes constant. Okay, so here the thing is, amplitude has to be increased, means the output must increase. So when the output is increasing, when the input is increasing, when the input is increasing, amplifier will increase this increased input and it gives the increased output. Okay, when this Xi will increase, yes, whenever this Xf is in phase with Xs, then Xi will increase. Means, suppose if Xs is positive, Xf must be positive. If Xs is negative, Xf must be negative. Or in the concept of angles, if it is 0 degree phase, it must be 0 degree. See, when this Xs is 0 degree, okay, listen carefully. Amplifier, suppose if the amplifier is CE, CE is the best amplifier. So, obviously in the oscillator circuit, CE amplifier is mostly used. But for the CE amplifier, we know there exists 180 degrees phase shift between the input and output. As it is giving 180, yes, even Xi is with 0 phase, X0 is with 180 phase. Okay, but this X0 is connecting to the feedback network, and the feedback network output must be of 0 degree. Okay, means the feedback network has to introduce another 180. Then this 180, yes, another 180, totally the angle becomes 360 or 0. Clear? Okay, otherwise I will explain through waveforms. Suppose Xi is like this. So X0 becomes, as this is 180 degree phase, X0 is like this. Okay? Xi is like this means Xs is like this. Fine. But here X0 is with 180 phase. Xs and Xf must be with same phase. Means the Xf signal must be like this. Means this should be rotated by another 180. So what about your Xf? Rotate this signal by 180. So you will get this. Okay. So totally this is your Xf, this is your Xs, this is your Xi, and this is your X0. What is the loop angle totally? If amplifier is introducing 180, feedback network has to introduce another 180. Then only Xs and Xf are with the same phase. That is called positive feedback. Okay. Yes, 360 degrees is equivalent to 0 degree. We know. So the amplifier is of 0 degree phase. Means if it won't produce any phase, then this X0 is with the same phase and this Xf is also with the same 0 degree phase. Then what is the loop angle? Means the angle inside this loop. This is 0 and this is also 0. Totally it is 0 degree. So what is the second condition under Barkhausen criteria? The second condition is the loop angle. That is, angle A beta must be either 0 degree or 360 degree. I'll tell you another point. Say this waveform. This is actually the output waveform of the oscillator. But we'll see only this. This constant amplitude. Circuit adjusts itself to produce only that output consisting of constant amplitude. See this portion. What is happening in this portion? Amplitude is gradually increasing. Okay. So in this portion, your loop gain A beta is greater than 1. Then only the amplitude will increase. But whenever the amplitude reaches some sustained value, means whenever the amplitude reaches our required value, designed value, then circuit adjusts itself to the A beta is equal to 1. Okay, then the oscillations will be sustained, means stable, and you're going to get that signal as output. Okay, you want to see this signal. Fine. So this is all about the oscillator principle. Okay, thank you very much.